Click the bell icon to get latest videos from Ekeeda.
Hello friends, the next question is a slight modification over the last question, but then you will see that for this particular question or for this particular language, we cannot design a DPDA, though we can design an NPDA. Let us see the question first. There is a slight modification in the question. Alice over here we have a slight modification of the language. L is a raised to n b raised to n such that n is greater than or equal to 1. L is a raised to n b raised to n such that n is greater than or equal to 1 with a union with just the string a. Similar to the previous question, let us split this language into two parts, L1 and L2. Let us say machine M1 is accepting this language L1. L2 is just the string A. Let us say L2 is accepted by machine M2. We can say that L is a union of L1 and L2. From previous questions, we know that both L1 and L2 are DCFL. We need to check is the complete language L is deterministic or not. That means, are we able to design a deterministic machine using machine M1 and M2? I'm going to combine machine M1 and M2. To join these machines, let us take a new state, QS, as the start state. Over here, let us see when to use machine M1 and when to use machine M2. We know that when the string is of the form a raised to n, b raised to n, machine M1 go to final state. Similarly, if the string is just a, machine M2 go to final state. But looking at the start of the string, can we predict is it going to be a final state for machine M1? That means whether the string is of the form a raised to n, b raised to n or just a single a, we cannot. That means this particular decision of whether to go with machine M1 or to go with machine M2 is not decidable at the first start of the string. As this decision is not possible, we have to simultaneously run both machine M1 and M2, and if any one of them is going to the final state, we can say that that particular string is accepted or else that particular string is rejected. This case, that is running two machines simultaneously, is possible only if we are designing an NPDA, not with a DPDA. And hence, we can say that this language is not deterministic, whereas this is generally a CFL, which is not deterministic. Generally, CFL are closed under union. That means if two languages are CFL, the union is also a CFL, but this is not the case with DCFL. We will discuss the closure properties of context-free languages later in the respective topic. For now, let us discuss a few more questions on deterministic PDAs. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.